Okay, so the final presentation of this session will be given virtually. So I think it's now getting set up. So the authors are Jieying here, Antje Meyer, Creemers, and Laurel Brehm. And
Thank you.
yeah.
Okay, thank you. I hope you can hear me very well, and I hope you can see my slides. And today I'm going to present our work, which explores the effects of irrelevant, unintelligible, and intelligible background speech on spoken language production. And this work is done by me and also with my supervisors, Antje, Eva, and Laura. And I think Laura is also here, so feel free to ask us any questions. Okay, in our daily life, conversation takes place in noisy environments with the sources of non-linguistic background noise, such as traffic and construction noise, and also with the sources of linguistic background noise, such as the radio and television noise. We all know that conversation is an act of coordination of speaking and listening. So to understand how people manage their conversation in noisy environment, we need to know how they listen to speech in noise and how they plan their speech in noise. So far, listening in noise has been widely exploited, but speaking noise is understudied. So this study explored how people produce their speech in background noise, especially in speech noise. We are wondering that whether and how background speech influences speech production and what properties of background speech interfere with speech production. And we also wonder that how can speakers copy with such an interference? Before we move to our study, let's take a look at the irrelevant speech effect. This effect refers to the finding that task-irrelevant background speech disrupts cognitive tasks relative to a quiet control condition. So, for example, this effect has been exploited in reading performance. When native English speakers were asked to read English sentences while ignoring background sounds, such as the unintelligible background sentence, like English sentence, or the unintelligible background speech, such as Chinese sentence, or in a speech spectrum noise. And they found that the participants' reading performance was disrupted more by intelligible background speech than by unintelligible background speech, and also more by speech spectrum noise. So one may ask, what is the underlying mechanism for the irrelevant speech effect? And here are two types of accounts which explain the irrelevant speech effects. The first one is the interference by process account. This account assumes that the involvement of shared processes and repetitions between focal task and background speech cause the interference. And this account can be divided into two specific versions. The first version is that the semantic disruption view, which assumes that the interference is actually semantic in nature, which means the shared use of semantic processing causes the disruption. So this view predicts that only the intelligible background speech causes the disruption, but the unintelligible background speech doesn't. So this has been supported by the finding that the reading performance is disrupted more than English, that is more than by the intelligible background speech than by unintelligible background speech. And the other version of the interference by process account is the phonological disruption view, which assumes that the disruption is actually phonological in nature, which means the similarity in the content of the phonological codes cause the disruption. So this view predicts that any speech sound should disrupt the language processing, but the acoustic noise doesn't. This has been supported by the finding that the acoustic noise in a busy bar didn't significantly impair reading comprehension relative to a quiet control condition. And the other type of account for the irrelevant speech effect is the attention capture account, which assumes that the background speech captures attention, resulting in fewer resources available to the focal task and causing a drop in task performance. So this attention capture account can be also divided into two specific versions. The first one is the specific attention capture view, which assumes that the attention is captured by the content of the stimuli itself, such as the semantic information of background speech. So in this case, the linguistic richness of background speech, such as semantic and phonological information, should disrupt the reading performance. The other specific Version is a specific attention capture view, which assumes that the attention is captured by purely the context in which it occurs, such as the sudden onset of speech following a period of silence. So in this case, only the varied context of the background speech disrupts the reading performance, such as the presence or the absence of pauses. So we are wondering whether and why irrelevant background speech affects speech production, and can we use these theories to explain the irrelevant speech effects in speech production? And here is the most relevant study that we conducted before, which explored whether representational similarity affected speech production. The design is a 2x3 design. Both factors are within subject factors. So the name agreement refers to the extent to which participants agree on the name of a picture. For example, if the picture is a cat, and it can be called cat, kitty, or pussy. So this is a low name agreement picture. But if a picture is butterfly, and it can be always called as a butterfly. So this is a high name agreement picture. Previous studies have found that it took longer to name low name pictures than name high name pictures. This is because the low name agreement evoke multiple lexical candidates and makes people to take longer to inhibit the other candidates and select the target name. So this means the name agreement can index the difficulty of speech production because the lexical selection for the low name agreement is harder than the high name agreement. We also manipulate the similarity between the speech production and the background speech. So here is our experiment task. Participants, native Dutch speakers, were asked to name pictures one by one in Dutch, while ignoring different types of background sounds. So in the high similarity condition, they needed to ignore the Dutch word list because the Dutch are totally intelligible speech, which share the semantic and phonological information with the speech production. So this is a high similarity condition. And in the medium similarity condition, they needed to ignore the Chinese word list because the Chinese is unintelligible to them, so which is a medium similarity condition. And they also needed to ignore the 8-talk bubble. This is a kind of speech-like noise without any linguistic information. So this is a low similarity condition. And we found that first, it took longer to name low name pictures than high name pictures, which means we found very stable name agreement effects. And we also found word lists disrupts the speech production more than bubble condition, which means it took longer to name pictures in the presence of word list condition than the bubble condition. And we also found that the Dutch background speech interferes more than Chinese background speech. So this results suggest that the increased reputational similarity results in more disruption, which is consistent with the interference by processor account. A very interesting finding is that we found the difference between the word list and bubble only for high name agreement, that is only for the easy picture naming, not for the difficult picture naming. So this result suggests that the interference by background speech can be reduced by increased difficulty of speech production. This may be via an attention engagement mechanism because the difficult picture naming makes speakers to concentrate harder and reduce the processing of the background speech. However, this study leaves some open questions. The first one is that this study didn't include the quiet control condition, so we don't know how unintelligible background speech disrupts the speech production relative to a quiet control condition. So the current study set up a quiet control condition to explore the extent of interference by unintelligible background speech. The second open question is that we are not sure whether the reputational similarity effect, that is a background speech effect, were also caused by the specific context variation, because the word list and bubble, they not only differ in the linguistic information, but they also differ in the specific acoustic variation, such, for example, the word list are the segmented words. segmented speech, but the bubble is just a continuous sound stream. So to test this question, we manipulated a specific context variation in the current study by comparing the Chinese word lists versus Chinese sentences. Because the Chinese speech are totally unintelligible to the native Dutch speaker, so the only difference is a specific context variation, that is the presence and the absence of pauses. The third open question is that this study just attributes the background speech effects into the interference by process mechanism, but these effects could also result from attention capture mechanism because the three different background speech, they differ in both a specific context and also specific linguistic information. This may lead to a specific and a specific attention capture. So to test this, we manipulate the specific context variation by comparing different types of Chinese background speech. And we also manipulate the specific context and specific linguistic variation by comparing different types of Dutch background speech. So here is our current study. First, we explored how different types of unintelligible background speech influence the speech production. So in the first experiment, we set 3 different background speech conditions. And in the second, we are wondering whether the influence changes when background speech is intelligible. So in the second experiment, we replaced all the Chinese background speech with the Dutch ones. And we are also wondering whether the irrelevant speech effects are modulated by the difficulty of speech production. So similar to our previous study, we also manipulate the name agreement in both experiments to index the difficulty of speech production, especially the difficulty of lexical selection of the speech production. So we conducted 2 parallel experiments. Both of them are 3x2 design. And both factors are the within subject factors. And first, we found a very stable name agreement effect. First, we predicted that we should find a very stable name agreement effect in both experiments. And the second, for the irrelevant speech effects, we made 2 contrasts. First is the speech versus quiet condition. Second is the word list versus sentence contrast. And the interference by process can make very clear prediction for our first contrast. That is to say, semantic disruption view predicts that only the intelligible background speech interfere with the speech production. So which means only the Dutch background speech in the second experiment disrupts more than quiet control condition, but the Chinese doesn't. But the phonological disruption view assumed that the any speech sound should disrupt the speech production. So this will predict that both Chinese and Dutch, they should disrupt the speech production relative to a quiet control condition. And the attention capture view can predict very specific predictions for our second contrast. That is to say, the specific attention capture view assumes that the content of the background speech itself causes the disruption. So in this case, this will predict that the Chinese word list should have the same degree of the disruption as Chinese sentences. But the Dutch word list may interfere less than the Dutch sentences because Dutch sentence contains more linguistic information than the Dutch sentence. But the specific attention capture view assumes that only the context in which it occurs, such as the presence or the absence of pauses, cause the attention capture. So this view predicts that both the word lists should disrupt more than sentences because the word list contains more acoustic variation and it should capture more attention. We also predict that the modulation of name agreement on irrelevant speech effects depends on the intelligibility. Specifically, in the first experiment, we predict there shouldn't be any interaction between the 2 factors. This is because a specific disruption of auditory input is rooted in the automatic processing that escapes cognitive control, so which should not be influenced by the task difficulty. But in the second experiment, we predict that there should be an interaction between the name agreement and the background speech. This is because the specific disruption requires central attention that taps into the cognitive control. And this disruption should be reduced by an increase in the speech production difficulty. And here is our first experiment. We explored how different types of unintelligible background speech affect the speech production and whether the influence was modulated by the difficulty of speech production. So as I just mentioned, the design is a 3x2 design. So in this experiment, native Dutch speakers were asked to name 4 high name agreement or low name agreement pictures in Dutch, while ignoring different types of Chinese background speech. And here is an example of the Chinese word list.
盾牌、游泳者、盘子、钱包、鸡、画框。
And here is also an example of the Chinese sentences.
画框和鸡在钱包的右边，并且盘子和游泳者在盾牌的左边。
And for the production performance, we measured a bunch of dependent variables because we think different variables should reflect the different aspects of the spoken language production. So, for example, the onset latency refers to this period, and the utterance duration refers to this period. And the total pause time refers to the sum of the pauses between the 2 consecutive speech responses. So in this case, the total pause time refers to the pause 1 plus pause 2 plus pause 3. And the articulation time refers to the sum of the articulations. And we are also wondering how participants group their speech responses. So we measure the chunk measures. For this kind of measure, we assume that if the pause between the 2 consecutive speech responses is shorter than 200 milliseconds, then we regard the 2 consecutive responses as a single chunk. So the total chunk number refers to how many chunks participants made on a trial, and the first chunk length refers to how many pictures they name in the first chunk. And here is the results of the first experiment. First, we found very stable name agreement effects on each measure, which suggests that it took longer, made more errors, and made more chunks when naming low name pictures than naming high name pictures. And the second, we found that the presence of Chinese background speech increased onset latencies and articulation time significantly relative to acquired control condition, which suggests that the Chinese speech causes disruption, which is consistent with the phonological disruption view. And third, we didn't find any difference between Chinese word lists and sentences, which may suggest that a specific context variation doesn't elicit auditory disruption, which in turn supports the specific attention capture view. And last, we didn't find any interaction between the 2 factors, which is also consistent with our prediction that a specific disruption is not influenced by task difficulty. So we are wondering that whether the disruptions generalize to situations with intelligible background speech. So in the second experiment, we explored how different types of intelligible background speech affect the speech production. So the design is also a 3x2 design, and we use the same task as the first experiment, but just replaced all the Chinese background speech with the Dutch background speech. And here are the results of the second experiment. And first, we replicated the stable name agreement effects on all measures. And second, we found that the presence of Dutch background speech increased onset latencies, utterance durations, and also articulation time significantly relative to acquired control condition, which suggests that the Dutch speech causes disruption, which is consistent with the phonological disruption view. And third, we didn't find any systematic difference between the Dutch word list and the Dutch sentences. The absence of the difference may be because a specific context effect and a specific linguistic effect cancel each other out, because the Dutch word lists contain more specific pauses but less linguistic information than Dutch sentences. And the other possibility for the absence of the difference between word list and sentence is maybe because the background speech stimuli are too boring, because the word list had a regular acoustic pattern, or because the background speech had a very uniform syntactic structure, because we use the background sentence that like the A and the B are next to the C and the D and the E are next to the F. And last, we found an interaction between the two factors here, which showing that the auditory disruption only for high number pictures, that is for the easy pictures, not for the difficult picture naming. So which suggests that the auditory disruptions can be eliminated by an increase in task difficulty. So to sum up, first, we found a very stable name agreement effects, which suggests that the lexical selection demand affects speech production. And second, we found that the presence of background speech disrupted speech production, which suggests that any speech, even unintelligible speech, is harmful for spoken language production, which supports the phonological disruption view. And third, we didn't find any systematic difference between the word list and the sentences in either experiment. This may suggest that a specific variation of background speech we manipulated in our study may not capture attention, supporting the specific attention capture view. And last, the auditory disruption by intelligible background speech can be reduced by an increase in speech production difficulty. This is maybe because the difficult speech production makes people concentrate harder and reduce the processing of background speech. So here is a take-home message for you. And our study, our work provides the first insights into the question that whether and how background speech affects spoken language production. And we found that background speech, regardless of its intelligibility, disrupts many aspects of the spoken language production. And importantly, speakers can manage the auditory disruption by changing when and how they plan their speech. And thank you very much. Any questions, comments, and suggestions will very be helpful. Okay, I'll stop my sharing.
Thanks very much. Any question? We've got plenty of time for plenty of questions. Okay, so while people are preparing, I have one question. So maybe I missed it, but did you predict any difference across the two languages? Did you predict the patterns of result will be different in?
Okay, thank you for your question. Yes, actually, we predict that the Dutch background speech should cause more disruption than the Chinese one, because Dutch are intelligible and has more linguistic information than the Chinese one. And actually, we also conducted the analysis across two experiments. And we found that the speech was quiet condition, this effect is really stable in the Dutch experiment, but relatively weak in the Chinese experiment. And we also found that the interaction between the name agreement and the background speech only in the Dutch experiment, which means when the background speech is intelligible, and this kind of auditory disruption can be eliminated by the task difficulty, but we didn't find this in the Chinese one.
Okay, thank you. So you said Dutch background speech was more intelligible. Is that just, was it an manipulation, or it's just that it happened? You created these speeches and they are more intelligible.
Sorry, what do you mean? I didn't understand your question.
Okay, so you said Dutch background speech was more intelligible, so you expected more interference. Now, was it just as it happened when you created the stimuli, or was it part of the plan?
Actually, it's part of a plan. Yeah, because we want to select two kinds of languages. They are really different from each other. So we just use the unintelligible and intelligible speech and to see what happens. And also because this is the first study to explore how background speech disrupts speech production. So we select two totally different kind of background speeches. But I think in our future work, maybe we can just use the all intelligible background speech, such as different types of Dutch background speech. And actually in the work we are working on now, and we ask participants to name pictures where ignore different boring Dutch sentences or the funny Dutch sentence. We are to say if the funny sentences will cause more disruption than the boring sentences. Yeah.
Okay, thank you. Any other questions? Oh, sorry, I can see.
Yeah, Ciolo Kapatzinski in Institute of Oregon. Very interesting work. I guess I was wondering, Chinese and Dutch are very phonologically different from each other. So I'm just wondering whether the phonological kind of, so for example, the fact that Chinese is a tone language, and so you get a lot of these kind of tone contours going up and down in a sentence, could that also create kind of more auditory interference, pushing against kind of the greater familiarity and meaningfulness of the Dutch? And so I'm wondering, could you create Dutch-like just nonsense, right? So like Dutch pseudo words, which presumably maybe would be a better control than
Yeah, yeah.
language.
Yeah, thank you very much for your suggestion. Yeah, it's really helpful for our work. Yeah, maybe in the next work we can create just like what you said. Yeah, thank you very much.
Any other question? Oh, sorry.
Yes, thank you. Very interesting work. Chiara Gambi, University of Warwick. I think my question kind of relates to the previous one in a sense. So I'm just wondering what participants in your experiments might have thought, essentially. I'll try to explain what I mean. So presumably, they've got this task of naming pictures, and that might be a fairly boring task in their native language. And then in one experiment, they hear background speech in their native language, whose content may be more or less interesting to them. And sorry if I missed it, but I don't know what the content actually was. Maybe you said it and I missed it. And instead, in the other condition, they hear a language they don't know. And, depending on different participant characteristics, some of them may actually have been more interested in that non-native speech and trying to work out what it meant, for example. Does this make any sense?
Yeah,
Or could
yeah,
it be
yeah.
potentially influencing your findings?
Yeah, it makes sense. Thank you very much for your question. And in our previous study, we use the Dutch word is just a list of 18 words within 12 seconds, and the Chinese word list also translation from the Dutch ones. Yeah, we totally agree with you that the unintelligible background speech may capture more attention because they are novel to the participants. Yeah. And in our future study, we'll totally take your idea into account. Thank you.
Thank you.
Okay, so let's thank the speaker once again. Thanks very much. Oh,
Thank you.
sorry, I have to correct it. Sorry, I couldn't see you. I thought you were the organizer.
Hi.
Bye.
I'm just gonna. Okay. Thanks for the talk. Very interesting. I'm Mariana Azad from New York University. So I want to ask you a question about unintelligibility. Suppose we put it on a gradient. So there are languages that are at least partially intelligible to each other, and in this example, Dutch and Mandarin are completely unintelligible. But what would be your prediction? Suppose that, for example, you had a gradient of the language that someone actually, like someone's native language, versus a language that they could understand parts of, even if they haven't taken any. For example, I'm thinking of Italian and Spanish as being partially intelligible to each other, versus a completely unintelligible language. So yeah, just intelligibility as a gradient, and what would you expect for that?
Yeah, thank you for your question, and also thank you for your suggestion, which is really insightful. Yeah, I think if we use a totally intelligible background speech, partly intelligible speech, and also the unintelligible background speech, I think we still can predict that the intelligible background speech interferes more than the partly one, and also more than unintelligible. I think so. but I'm not actually sure because maybe the partly unintelligible background speech capture more attention, but I'm not sure. But this is definitely a good idea.
Okay, thank you.
Yeah, thank
I
you.
have to apologize. I thought you were talking about bilinguals. That's why I'm talking about asking about. Sorry, so my question completely wrong. So this is a suggestion for future chairs. Don't ask question while you are timing. And then yes, okay. So well, thank you. That makes absolute sense. Okay, any other questions? Right, so we have half an hour break. So I suppose there will be some refreshments. Okay, and then let's reconvene at 4:30. Thanks very much.
Thank you.